Hi everyone, welcome back. Today we'll be starting Chapter 11 on quadratic equations and functions. Specifically today, 11.1, solving quadratic equations by completing the square. So we're going to start this with a quadratic equation that we could have solved using Mth100 methods. So this one, if we used our Mth100 methods, aka factoring, we would simply set one side equal to 0, factor, and solve. So we set one factor at a time equal to 0. So x is -4 or x is +4. We do have another option when we have the format of a perfect square equals a constant. And that is the square root method. If I take the square root of x squared, I'll leave a little room here, we're going to need it in a minute. And the square root of 16, square root of x squared, we can think of as x. Square root of 16 is 4, but notice that's only one of our two solutions. So anytime you're introducing a square root to an equation that did not have it before, you need to include a plus or minus, including on that first step where you take it. So then we have two solutions. X is plus or minus 4. Where that comes in handy is problems like x squared is equal to 20. This one we couldn't solve with Mth100 methods. We'd be looking for two integers that'll multiply to -20 and add to 0. There are no pairs of integers that will do that job. There are numbers that will do the job, just not integers. So this one we would have to do the square root method. As you can hear, I am quarantined with my wife and 8-month-old. So thanks for your patience with that. Okay, left-hand side, square root of x squared, we'll just put down an x and plus or minus. And just like any of the chapter 10 problems, we look for any simplifying we can do. 20 has a non-trivial perfect square factor, so we break it apart. So x is plus or minus 2 root 5. So there are a pair of irrational numbers that will solve the equation. There are no integer solutions to that equation. Directions typically would be solve. Occasionally they'll say solve using whatever particular method. So the next one, again, they're just going to say solve unless we're telling you otherwise. 5x squared minus 55 is equal to 0. I'd like it to look like the others. So I'll add 55 to both sides. So 5x squared is worth 55. We'll divide both sides by +5. And now we have it where the others started. X squared is equal to 11. I'll do the square root of both sides then. As soon as you introduce a square root to an equation that didn't have it, you have to include a plus or minus. Yes, it has to be there. Yes, even on that first step. Left-hand side simplifies to an x. Right-hand side plus or minus root 11. 11 is a prime, so no non-trivial perfect square factors. All right, so I'll have you all try one out. So just copy the problem down, pause it, try it out, and then we'll finish it together. You're going to be solving 2x squared minus 16 is equal to 0. Okay, welcome back. Hopefully you paused it and tried it by now. So we want to get perfect square equals constant. So 2x squared equals 16. Divide both sides by 2. X squared equals 8. Square equals constant. That's the format we want. So then we'll take the square root of both sides, which means we have to include that plus or minus. So x is equal to plus or minus square root of 4 square root of 2. So x is plus or minus 2 root 2 is our final answer. Now, it won't always be just an x that is squared. Occasionally, we'll be asked to solve something else that has that same basic format, but more going on that is squared. So we'll start with an x plus 2. Quantity squared is worth 18. We still have the format of square equals constant. So we'll use that same square root method. I'll take the square root of x plus 2 quantity squared, plus or minus on the side with the constant, plus or minus square root of 18. Left-hand side, again, I'll think of the square and square root as inverse operations, and that'll give me just an x plus 2. Right-hand side, we'll simplify where we can. 9 is a perfect square, 2 is not. So x plus 2 is plus or minus 3 root 2. But we're not done yet. The reason we know we're not done yet is I don't just have an x equals some numbers. This 2 is in the way. Well, at this point, it's a linear equation, really a pair of linear equations. So I'll subtract 2 on both sides. So x is negative 2 plus or minus 3 square root of 2. So again, a pair of irrational numbers for our solution. So next up, we'll try out 3x minus 1 quantity squared is equal to negative 4. Something brand new on this one. Perfect square equals negative. That tells us we're in 10.7 territory, imaginary numbers appearing. So we're in the right format. Perfect square equals constant. We'll do the square root of both sides. Left-hand side, square and square root are acting as inverse operations, so we get a 3x minus 1. Plus or minus, square root of 4 is 2, and since we have the square root of a negative, I comes into the problem. After that, we solve it as if it's one linear equation, even though really it's two separate linear equations. So 3x is worth 1 plus or minus 2i. Divide both sides by 3, so x is a third plus or minus 2/3 of I. So this time, two complex solutions. All right, so we'll have you all try one out. So you're going to try 2x plus 1 quantity squared is worth negative 81. Let's go ahead and pause it, and we'll continue when you're done. Okay. You have the right format. Perfect square equals constant. Square root starts us off. Plus or minus on the side with the constant. That always has to be there if you're introducing a square root to an equation that did not have it. So left side, 2x plus 1. Right hand side, plus or minus. Hopefully you figured out that that was a 9i. After that, we solve the pair of linear equations. So 2x is negative 1 plus or minus 9i, and we divide through by 2, so x is negative 1/2 plus or minus 9/2 of I. All right. So far we've looked at just a quick little mini review of the factoring method, and these have all been square root methods. Next we get into the idea of completing the square. The easiest way is to jump in with sort of a simpler example, and we'll build in complexity from there. So we'll start with x squared plus 8x minus 1 is equal to 0. Now, even if they didn't tell me to solve by completing the square, I definitely would not be able to complete this using Math95 methods. Reason being, notice I'm looking to multiply to -1 in a way that will add to +8. Not going to happen. If I'm using integers to multiply to -1, my only option is 1 times -1, which has a sum of 0, not 8. So what we're going to do is move that 1 out of the way for starters. So I'm going to have x squared plus 8x, and I'll leave a little bit of room, is equal to 1. Then I'm going to check to make sure that a is equal to 1. A is equal to 1. If that's the case, then we do b divided by 2 and square the result. So these are assuming that we're in ax squared plus bx plus c equals 0 form. So here my a is worth 1, no problem. B here is 8, so we're going to off to the side do 8 divided by 2 squared, which is 4 squared, 16. I'm going to add 16 to both sides of the equation. As long as I'm adding the same thing on both sides, we are still okay. Addition property of equality. So the right-hand side, you'll probably notice, is 17. The left-hand side, if we factor that, I'm now looking for a pair of integers that will multiply to +16 and add to a +8. Well, notice 4 and 4 get the job done. That's the idea, is it's the same number twice. So instead of x plus 4 times x plus 4, we'll put that down as x plus 4 quantity squared. If you want to convince yourself that that's true, you would not typically do this in actually solving this equation. But if you want to convince yourself that that's equal to the previous step, go ahead and FOIL this out and make sure that your left-hand side, you get an x squared plus 8x plus 16, and your right-hand side, you get something worth 17. Now that we're in that right format, now we can go back to the square root method. So completing the square always ends with the square root method anyway. So square root of x plus 4 quantity squared is plus or minus square root of 17. So x plus 4 is plus or minus root 17. And we finish it off subtracting 4 on both sides. So x is a -4 plus or minus root 17. So definitely not one we could have solved by factoring. Let's see, our next one we'll do r squared minus 5r plus 2 is equal to 0. This one's going to let us play with fractions a little bit, but otherwise isn't any different. So this one we're again going to solve by completing the square. So 2 is definitely not a perfect square. We'll move that out of the way. R squared minus 5r, I'll leave a little room, is equal to -2. I'll check that a is equal to 1. The number in front of the square is unwritten, so it's assumed to be 1. If it's not, we just use the multiplication property of equality to fix that. So here, again, we're going to do the b over 2 quantity squared. So negative 5 over 2 quantity squared. Negative times a negative is a positive. And 5 halves times 5 halves is 25 fourths. The negative 2, if it helps you, think of it as negative 2 over 1. So left-hand side, we're looking for a pair of, this time, rational numbers that will multiply to 25 over 4 and add to negative 5. Notice that also is the inside of our parentheses, just like last time it was. 4 and 4 added to 8 multiplied to 16. Negative 5 halves times negative 5 halves is 25 over 4. Negative 5 over 2 plus negative 5 over 2 is negative 10 over 2. Negative 10 over 2, though, simplifies to negative 5. So the left-hand side is now our minus 5 halves quantity squared. Right-hand side, negative 8 fourths plus 25 fourths. And a little cleanup on the right side before we continue. So our minus 5 halves squared is worth 17 fourths. Now we have that format. Perfect square equals constant. Square root of both sides, plus or minus on the side with the constant. So left side is now our minus 5 halves. Right side, plus or minus root 17 over square root of 4 is just a 2. So we'll add 5 halves to both sides. Just continue up here. So r is then 5 halves plus or minus root 17 halves. And sometimes you'll see it written as one fraction. Those two are equivalent. Those 4 really, since we have the minuses as well. Okay, so I'm going to put one up for you all to try out, and we'll finish it together. You're going to try out x squared plus 7x plus 2 is equal to 0. Okay, welcome back. Hopefully you started by moving that 2 out of the way, giving us x squared plus 7x, leave a little space, is equal to negative 2. Leading coefficient a is a 1. So since that's the case, we can do half of 7 and square the result. So that is 49 over 4. That's what we will add to both sides. Which means this negative 2 is now negative 2 over 1, or negative 8 over 4. So left side is x plus 7 over 2 quantity squared. Again, if you want to convince yourself of that, go ahead and write 2 of them out and FOIL them out, and you'll see that it does simplify to what we had there. Right-hand side, negative 8 fourths plus 49 fourths. So x plus 7 halves quantity squared is equal to 41 fourths. And that's where we introduce our friend the square root on both sides. So x plus 7 halves on the left-hand side, right-hand side, plus or minus root 41 over 2. And we subtract 7 halves on both sides. So x is negative 7 halves, plus or minus root 41 over 2. Or if you want to put them together, negative 7 plus or minus root 41 all over 2. 2 different ways to write the same thing. Okay, so Then our last couple examples in 11.1, we don't meet that first criteria of a being worth 1 anymore. So we'll do 3x squared plus 3x plus 4 is equal to 0. Now certainly we can move the 4 out of the way. Same directions as before, solve by completing the square. Okay, so we have 3x squared plus 3x is equal to negative 4. Now here, notice that a is not yet worth 1. I have this coefficient of 3. I'll simply divide both sides by 3. So that gives me 1x squared, or simply x squared, plus x, or 1x, is equal to negative 4 over positive 3. Now that a is worth 1, now I'll do half of b and square that result. So that is 1/4. So that's what I'll add to both sides. So notice we want a common denominator of 12 there. So left-hand side, x plus 1/2 quantity squared. Notice that is what's inside our parentheses. Right-hand side, let's see, that would be negative 16 twelfths plus 3 twelfths. So x plus 1/2 quantity squared is worth negative 13 twelfths. Square root of both sides. So left side, x plus 1/2. Right-hand side, plus or minus I root 13 over 12. I'll break into a square root of 4, square root of 3. So x plus 1/2 is equal to plus or minus I root 13 over 2 root 3. And just like in chapter 10, we don't want to leave any radicals in the denominator. So this one I'll multiply top and bottom by root 3. So x plus 1/2 is equal to plus or minus I root 39 over 2 by 3 gives you a nice pretty 6. So we'll subtract 1/2. So we can say x is negative 1/2 plus or minus I root 39 all over 6. Or if you want to put them together, 1/2 is the same as 3/6. So those two are equivalent. Okay. So let me have you all try one out. It's a little bit shorter than this last one, but same directions as above. Solve by completing the square. Your new problem though, 2x squared. My apologies there. It should be minus 2x. Plus 7 is 0. So I'll give it a pause, try it out, and we'll finish it together. Okay, so hopefully you started with subtracting your 7 on both sides. 2x squared minus 2x is worth negative 7. A was not worth 1 yet, so we divided both sides by whatever a was, giving us x squared minus 1x is worth negative 7/2. So then you did half of negative 1 and squared the result. Negative times a negative is still a positive. So you added 1/4 to both sides. So left side, x minus 1/2 quantity squared. Right hand side, negative 14/4 plus 1/4. So x minus 1/2 quantity squared was negative 13 all over 4. Now we have the format we're after. Perfect square equals constant. Square root time. Yeah, whatever you do to one side of an equation, of course you do to the other. Make sure you include that plus or minus. So x minus 1/2 is now plus or minus I root 13 because that 13 was a negative. Square root of 4 is just a plain 2. So we finish it out, adding a half to both sides. So then x is a half plus or minus I root 13 all over 2, or you can write it as one fraction. Okay, so that does it for the 11.1 problems. Completing the square method, huge topic in college algebra, huge topic in pre-calc, so you're going to need this one a lot. Spend a lot of time with this one. Really get to know this method inside and out. Let me get you your problems to try out. So, here we go. So this was section 11.1. I would recommend 1 to 73, every other odd, 75, and 77. If you have questions, please feel free to email me. Otherwise, I will see you next time.